Hey folks, welcome back as we finish up the unit on right triangles in trigonometry with our last of the videos on angles of elevation and depression. Hopefully you recall that we have already learned about identifying which angles are angles of elevation and depression, and already have learned about using the angle of elevation. And now what we're going to do is use the angle of depression, and then we will be versed in all things that are awesome about trigonometry in this class. So let's use the angle of depression in a couple of examples. So here's an airplane example, and we're going to talk about an approaching airplane who is approaching a runway of an airport in Oklahoma. The pilot has to begin a 3-degree descent starting from a height of 2,714 feet above sea level, and the airport is already above sea level. So that's an interesting thing. Then what we're going to do is to the nearest tenth of a mile, find out how far from the runway is the airplane at the start of the approach. So this is an interesting question because this question has a history of disagreement. Are we talking horizontal distance, or are we talking of the hypotenuse? Versus the hypotenuse. So this is an interesting question, and many teachers go one way or the other. I personally am a believer in horizontal distance, especially when it comes to air travel, because most mapping functions, air traffic control, for example, use overhead, and when they talk about how far from a runway is something, or in this example is a horizontal distance. So are we looking for the horizontal distance, which is this, or are we looking for the hypotenuse, which is this? And we never quite can come to agreement. Personally, I believe when we ask the question like this, how far from the runway is the airplane at the start of the approach, we are talking horizontal distance. That is the most sensical, the most realistic question that's there. So we should know that first. The second thing we should know is look out for the trick, because the airport is 1,007 feet above sea level. Okay, so the airport is above sea level already. So we have an amount of distance that's here, 1,007 feet. It's above sea level, and so sea level is down here, let's say. And why is that important? Because the height of the airplane right now is 2,714 feet above sea level. So the airplane itself is not 2,714 feet above the line of the airport. It's above sea level, right? So the whole thing is 2,714. That's going to be important because we have to know about the triangle that we're dealing with, our right triangle in question. No matter what we're talking about, if we're talking about horizontal distance or we're talking about the hypotenuse, no matter what, we have to be careful with this setup. So this is a neat question. It has a lot of wrinkles to it, and we'll want to work with that. So are we looking for the horizontal distance, or are we looking for the hypotenuse? Okay. The other thing I think is a neat thing to consider is notice how the degree of descent is used. It's starting at a 3-degree descent, which means the angle of depression is 3 degrees, which means also that the angle of elevation is 3 degrees. And that is an important thing to recall as well. Okay, so all of these things come into play with this question, which is why I waited for the third installment of the video for this one. So let's dive in. Okay, what I'm going to do since I made a mess of the picture, but B, since I want to figure out what it is that we are working with our right triangle. We are working with a 3-degree angle for elevation, which is the same thing. And we have to figure out our height. Now our height is not going to be 2,714. Our height is also not going to be 1,007, but what we get when we subtract the two. And so we're going to do a quick subtraction deal. If I know how to, I should be able to do this in my head. I just don't feel like thinking right now. So I'm going to subtract super quickly. And we have 1,707 And so our plane is actually 1,707 feet above the line of the airport. Not above sea level, but above the line of the airport. So no matter what we're going to find, if we're going to find the horizontal distance or if we're going to find the hypotenuse, either way, we'll have to know what it is we're looking for. And since, again, I'm a fan of finding the hypotenuse, we have to figure out, well, which is the function that we're going to use. Remember good Chief SOHCAHTOA. Okay, so we're gonna recall which function we're dealing with. Our angle is here. We have clearly the opposite side, and so it all depends on what we're looking for. If we have the opposite side, if we're finding the hypotenuse, we would use the sine function, and if we were finding the horizontal distance, we would use the tangent function. And again, since I want to do it my way, I would say we're going to use the tangent function. So we'd then say the tangent of 3 degrees would be equal to the opposite over the adjacent, the 1,707 feet over the horizontal distance. That would be the formula I would use. If we were talking about the hypotenuse, people would say, well, the sine of 3 then, right, the sine of that 3-degree angle measure would be the opposite over the hypotenuse. So it depends on how you're viewing the question, how far from the runway. Either way, let's solve it, right? So we do our little cross multiplication deal for the tangent. We find out that x would be 1,707 divided by the tangent of 3. And we can do a little bit of number crunching. So let's do that. 1,707 divided by the tangent of 3. And that would give us about 32,000 feet. And so we want to read the question again. And the question is asking about to the nearest tenth of a mile. Well, that's interesting. To the nearest tenth of a mile. And this is the number of feet that we have. So the feet that we're dealing with, 32,571.5 feet. Okay, so 32,571.5 feet. That's not miles, okay? That's feet. So what about miles, okay? Now, if we recall a quick conversion, did you know that 1 mile is equal to 5,280 feet? That's an interesting thing to recall. So we can use quick division, or we could use dimensional analysis, right? So 1 mile is 5,280 feet, and then we'll be able to have our answer in miles. Feet cancel, so we know what we're going to have. So we will divide that by 5,280, and that would give us the number of miles. And so we have in the calculator that shows us 6.168. We're looking to the nearest tenth of a mile. That would be 6.2 miles. So the result then would be 6.2 miles. That would be the answer for horizontal distance. Okay, for horizontal distance. If it was the hypotenuse question, which really has no meaning, but let's say it was, we can work it out the same way. So we'd have 1,707 divided by the sine of 3, and then we can use our calculator for that as well. 1,707 divided by the sine of 3, and that would equal 32,616.2 feet. But again, we will be dividing that by 5,280. So we would divide that by 5,280. That would give us the number of miles. In this case, it would be 6.2 as well. So we would luck out no matter what. 6.2 miles either way. So careful on that, because it turns out we'd get the same result, but we would still be looking at certain things. And when it comes to air traffic control, tiny mistakes like that could result in a lot of casualties. So we do want to be careful, especially when talking about horizontal distance. So that's the angle of depression in use. Let's do a couple more examples and go a little bit quicker. So here's an example. It's all words. All right, so here we go again. An airplane pilot sights a life raft at 26-degree angle of depression. That's interesting. The airport's altitude is 3 kilometers. What's the airplane's horizontal distance, D, from the raft? So at least now it's telling us, hey, horizontal distance, finally a real-world problem. So what's happening? What do we do? Let's draw a picture. So we have our airplane, and then a neat airplane. So we draw our airplane, and it sights a life raft somewhere. Okay, so It's going to sight a life raft somewhere. Let's draw a little life raft. Here's my little boat. Boop, boop. And here's what's interesting. At a 26-degree angle of depression. So what does that mean? That means the angle of depression, folks, is, remember the original note, the angle of depression is up here. That's our 26-degree angle of depression. So we have to remember the vocabulary from our first video. And if that was confusing, make sure you go watch video number 1. That's where we figure that out. And the question is about the plane's horizontal distance to the life raft. So that's the plane's horizontal distance. And how can we figure horizontal distance? Well, it's based off of altitude. Okay, so we have our right triangle, and the altitude in the problem was 3 kilometers. Okay, so we have our 3-kilometer altitude. We have our angle of depression. We have our life raft. So we clearly can start seeing the function that we're going to use. Hopefully you already see the trig function that we're going to use. Now, if our 26-degree angle is our angle of depression, that means from the life raft to the plane is also 26 degrees. And now we have our angle of basically our perspective angle. We have the 3 kilometers is opposite, and what we're looking for is adjacent. Okay, so 3 kilometers is opposite. What we're looking for is adjacent. That, of course, is our tangent function. Tangent is the opposite over the adjacent. And so we'll be looking at the tangent of 26, and that would be 3 kilometers over what we're looking for. And so that is the equation. That's the hard part. And so we do a little quick algebra. X would be 3 divided by the tangent of 26, and that's where the calculator comes in. So we'd have 3 divided by 26 tangent, and that would give us 6.15 kilometers. So now, before I answer the question, we got to look at, do we round it or anything? So what is the airplane's horizontal distance d from the raft? It doesn't tell us to round, so we'll stick with 6.15. How about that? So x equals 6.15 kilometers, and then that will tell us, how long it will take, or how fast we can get to the life raft, or how much we can rescue the person that's in there. And that's using the angle of depression. Quick quiz, and then we are done. So let's do a quick quiz here. Let's see. Kurt leans a 20-foot long ladder against the side of the house. Let's do that. See that? How quick you can draw a 20-foot ladder leaning against the side of the house. Look how fast it's drawn. The ladder reaches to a height of 18.9 feet. Okay, so we have that. What is the angle of elevation of the ladder to the nearest 10th degree? So the question is asking for the angle of elevation. So with the given figures that we have an opposite and a hypotenuse. That means we're going to be looking for the sine. So the sine of the angle would be 18.9 over 20. Do you remember how we do this? We have to use the inverse sine. Okay, so we're going to look for the inverse sine of 18.9 over 20. So the rest is calculator work. 18.9 divided by 20. And then we're going to use the inverse sine. And that's going to give us 70.9. 70.9. Nice and fast. Here's another one. You sight the top of a 50-foot tree from a point on the ground. Okay, so here's you. Here's a tree. And you sight from a point on the ground 50 feet. Okay, so we have a 50 feet from the base of the tree. And the tree was, let's see, you sighted the top of a 50-foot tree. Okay, so the tree is 50 feet. What is your angle of elevation? So the question is, what is your angle of elevation? I am not going to use my calculator on this one. Why not? Because we have a congruent leg and a congruent leg. We have a certain type of triangle. Do you remember what type of triangle that is? That's the old 45, 45, 90 right triangle. That means the angle of elevation is 45. So we have to remember shortcuts when we see them. And that's it for trigonometry. So folks, I hope you enjoyed the lesson on angles of elevation, depression. I hope you remember all your stuff about trigonometry and everything, because that is it for the unit. And I want to thank you for your time and attention. Bye-bye.